Howdy, my name is Richard Beck, and I'm a student in electrical engineering here at Utah State.
Hello, my name is Cedric Manning, and I am a student at Utah State studying computer engineering.
Today we're excited to present to you our senior design project. This is our exercise bike generator.
So basically what we did was attach an alternator to a stationary bike on a frame, and that alternator supplies power to a boost converter, which then will be able to charge a battery.
There's a couple reasons that we wanted to do this project. One of them is that renewable power is a really big thing these days. And just as we thought about it, there's a lot of energy that gets produced and wasted as people go to the gym and exercise, and we wanted to see if we could figure out a way to harness that energy. And so we decided to start with an exercise bike, since that's a really common thing you find at the gym.
So now we'll be going into how we put the system together and how it all works. To begin, we put a bicycle frame on a stationary frame and put the alternator also on the frame and connected the alternator to the bike here, to the rear rim. It's connected with this serpentine belt here, and a user will pedal and will be able to turn the alternator here. One of the components of the system is the gears on the bike here. It will allow a user to spin the alternator pulley fast enough to generate the power.
The next thing we needed to do was figure out how to process the output that we got from the alternator. As you may know, alternators do not produce very clean power. It has a lot of variation, and it's about 14 volts, which really wasn't enough for us to charge the battery that we had. So here on this side, right here, is the boost converter that we designed and built from scratch in order to process that 14 volt output. We've got several capacitors here, we've got an inductor, and we've got some switching elements here that actually switch at 50,000 times per second. And putting all those components together allows us to get from 14 volts up to in the range of 24 to 30 volts. And not only does it boost the voltage, but we actually have full control over the output voltage and the input current. And this is really where all the control for the entire system comes together.
On this side here of the system, we have the microcontroller here, which monitors the battery's state of charge. It will be able to regulate the output current and is also the main control for the resistance control module, which we will get into later.
Here we have our 24 volt battery. This is where we store the energy that we produce by pedaling the bike. And one of the things that we had to think a lot about was, how do we safely charge this battery? If you overcharge a battery, then there can be hydrogen gas that gets produced. It can be dangerous. You can damage the battery. There's kind of a lot to think about. And so we had to figure out a good control scheme that would let us do that. The other complication is that we wanted the user to be able to change the resistance of the bike and how hard it was to pedal so that they could have a good exercise experience. And so what we decided to do was to use a multi-rate constant current charging scheme in which the user can actually select 6 different levels of how hard it is to pedal the bike, and based on the level they select, a different current will be input to the battery. And as the battery increases in charge, the controller that Cedric mentioned earlier will actually automatically decrease the resistance level of the bike and not allow the user to select a higher resistance, which would damage the battery, until some of this power that's been stored in the battery has been used and discharged. Over here, just real quick, this is the resistance controller that we used. It's just a little rocker switch, but as the user is pedaling, they can use the switch to increase or decrease the resistance levels that they want to use.
In addition to storing power in the batteries, users will be able to hook up a power inverter. These are very cheap, they're cost effective, and it will enable them to power most of their household electronics.
All right, here we go. This is in the charge state 1, which is like one of the lower resistance levels. I'm now going to switch to charge state 2. You see the voltage starts to go up. Now the controller is trying to achieve a higher input current, and then also this corresponding to a higher voltage. I'm actually going to go up one more time. Charge state 3. And raise it up higher. It's definitely getting harder to pedal. Good workout. Thanks for letting us tell you about our project. We spent a lot of time working on this, and it's been a lot of fun, and it sure means a lot that you would take the time to let us share our work with you.
Yes, and in addition, we would like to say thanks to Dr. Hongji Wang and Dr. Donald Cripps for helping us with this project.
Their experience and advice has been invaluable in helping us overcome some of the obstacles we faced.